Assalamualaikum and good morning. For mini project ECW47 Hydraulic Laboratory, our title is Orifice Coefficient. First, my name is Nur Aji Shakira Binti Azril, number ID 2023-466058. I would like to explain about Orifice Coefficient for introduction. The Orifice Coefficient represents the ratio of the actual flow rate through the orifice to the theoretical flow rate predicted by an ideal fluid mechanics equation. Objective for this experiment to identify the coefficient of discharge for a small orifice based on flow under constant head and flow under varying head. Second, to analyze impact of orifice when a different diameter. Third, to identify the pattern of needle and slope of the graph based on the flow of orifice. Lastly, to describe the practical implication of the orifice coefficient in engineering application. Problem statement. So the conduct experiment on computing the value of coefficient of discharge. The CD coefficient discharge can be obtained according to the different type of flow, which flow under constant head and flow under varying head respectively. To determine the value of coefficient discharge from the different slope of the graph for both flow condition. Next, basic concept. The orifice coefficient experiment is based on the principle of fluid mechanics. When a fluid flows through a different diameter pipe, it experiences a change in velocity. The discharge formula states that the diameter of the pipe is inversely proportional to its velocity. Therefore, as the diameter increases and the velocity will decrease. In this experiment, the orifice coefficient will be determined by measuring the distance in the y and x direction of the water flow through the orifice. This will be done using different orifice diameter to study the effect the variable on the orifice coefficient. This is the apparatus orifice coefficient. Cylinder used to calculate Q, receiver, water tank, proboid, measure plot graph, orifice have two diameter, 4 mm and 8 mm. Last apparatus, hydraulic bench. In this experiment, I will use orifice with a diameter of 4 mm. First, measure the diameter of orifice. Diameter of orifice is 4 mm. Place the orifice 4 mm diameter at the tip of receiver. Next, measure and level height for 1, 2 and 3. Record the data. Next, prepare the paper for plot graph. Turn on hydraulic bench, then adjust the water flow. Pull overflow until the water fills at the level of height 1. Make sure the water is in a control state without wave. To record the data, firstly we need to adjust the needle of the probe to be just in contact with the water jet. Next, record the needle height of the probe profile on the paper. Lastly, measure the flow rate Q that the water exits through the orifice and the time is recorded for each 500 ml of water. This is result experiment for H1 and this shows that the result of H2. And lastly, repeat the step to get the result of H3.
My name is Nur Shaira Natasha binti Mazlan. My matrix number 2023444816. I will continue to present about results that we obtained from this orifice coefficient experiment. For this experiment, we took 3 trials. First, we used 0.004 meter for the diameter of orifice. Next, the head level for all 3 trials is different, which is trial 1 is 0.340 meter, trial 2 is 0.404 meter, and trial 3 is 0.460 meter. For volume, we use 0.0005 meter cube to take the time taken. The time taken for trial 1 is 18.31 second, trial 2 is 17.7 second, and trial 3 is 16.03 second. So, to find the flow rate, which is Q, we need to use the formula which is volume per time. After doing the calculation, the flow rate for first trial is 2.731 meter cube per second, trial 2 is 2.929 meter cube per second, and the last flow rate for trial 3 is 3.119 meter cube per second. After that, for this experiment, we need to find the distance from graph which is x and y. The distance can be obtained from the graph that we plotted earlier by do this experiment orifice coefficient, which is x is horizontal and y is vertical.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Fatihah binti Anwar. My matric number 2023444472. So today I'm going to present about the sample calculation for the trial 1. So first step, find the value of flow rate Q using the formula CV divided by T, which is 0.005 divided by 18.31. The answer that obtained is 2.731 multiplied 10 power of negative 5 meter cube per second. So for this experiment, the diameter is 0.004 meter. So find the area of orifice A using the formula pi t square over 4, which is pi multiplied with 0.004 square root of 2 divided by 4. The answer that's obtained is 1.256 multiplied by 10 power of negative 5 meter square. So for this experiment, because value of x1 and y1 is 0, so take the x2, which is 0.070 meter, and y2 is 0.004 meter. So find the coefficient of velocity CV using the formula x divided by 2 multiplied with the square root of y and h. The answer that obtained is 0.095. Lastly, to calculate the coefficient of discharge CD, the formula is Q divided by A multiplied with square root 2 multiplied with G and H. The answer that obtained is 2.643 multiplied 10 power of negative 3. Next, for this experiment, the graph showed that head level H with unit meter against flow rate Q with unit meter cube per second. So y-axis is head level H and x-axis is flow rate Q. For this experiment with 3 trial, the line graph illustrates higher head level readings with increasing flow rates.
One of engineering applications that can apply based on orifice coefficient is hydraulic and environmental engineering. The example from hydraulic and environmental is water treatment plant. There are various components that can be used in this application. For the first component is flow measurement and control. The case is flow meters in water treatment plants measure the flow rates of water and chemical. So the application is calibrate the flow meters using the discharge coefficient, which is CD, obtained from the orifice coefficient experiment to ensure accurate flow measurements. Another component is hydraulic design. For this case is design pipelines and channels for transporting water between treatment stage. The application can be with utilize the discharge coefficient to design the pipelines and channels with minimal energy losses and turbulence, ensuring smooth and efficient water transport.
Furthermore, the next application for orifice coefficient is flow measurement. So basically, the orifice coefficient is a dimensionless factor used to characterize the flow of fluids through an orifice. So orifices are commonly used in flow measurement devices such as orifice plates in orifice meter. It may be installed in pipeline with a minimum of trouble and expenses. The orifice coefficient helps in relating the pressure drop across the orifice to the flow rate of the fluid passing through it. By knowing the coefficient and measuring the pressure drop, engineers can accurately determine the flow rate in pipelines.
My name is Nurul binti Amisran. My metric number is 2023465766. The calculation of the orifice meter coefficient can be divided into two parts, the coefficient of velocity and the coefficient of discharge. From this experiment, the coefficient of velocity for 4 mm is 0.095 and the coefficient of discharge is 2.643 times 10 negative 5. The amount of water that flows out of the orifice depends on the flow rate and water level in the supply tank. According to the principle of fluid motion, the velocity increase and the pressure inside the fluid decrease as the orifice area decreases. This is our conclusion. According to the result of these experiments, the flow rate affects the coefficient of discharge, and the higher the discharge coefficient will be, the lower the flow rate. It was discovered that the flow rate hardly affected the coefficient of discharge if the pressure tapping were placed in a different pressure. We also can conclude that the increase in the diameter of orifice will increase the volume of fluid discharge as pressure acting on it increases.